Hey students, welcome back to Diksha Vedantu English channel. This is Suhas, your chemistry master teacher. Students, before starting the class, let me know in chat section. The PPT is clearly visible and your Suhas sir voice is clearly audible. If it's visible and audible, let me know in chat section. My dear students, come on, let me know. Check. Everybody check it. Students, we know, right? Structure of atom. This is an basic. This is a basic unit from your class 9, but students, which include basics, we have some more important topics. Still, what do you know? Electronic configuration is nothing but depends. Only for starting 2 8 that thing you do, right? Anubhav Rai, hi, Natraj, hi. As students, how was the Josh? Students, this is an class 11 topic, structure of atom, and also from this chapter, for your board exams and also for your JEE NEET, minimum 12 to 16 marks are coming, students. Just imagine, this chapter is very important. Up to till what we know, up to Bohr's model we know, Dalton's calm and discovery of subatomic particles, and we know about that. Right, students? Hi, Hema. Right, my dear students? Students, what we know in class 9, Dalton he told what he told. Atom is an indivisible particle. But what happened? After discovery of subatomic particles, J.J. Thomson discovers electron. And who discovers proton? Let us know. Let us know in it is for JEE Advanced. Yes, it's also important for JEE Advanced and above. For class 11 students, JEE Advanced, for NEET students, everybody. This is for everybody. JEE, NEET, NTSC, Olympiad, everybody. This unit, very important. Okay, students, what we know? That thing we know. And after discovery of electron done, by using discharge tube method, discovery of proton done, discovery of neutron done, some other scientists come, they imagine the structure of atom, they explain the structure of atom, right, my dear students? Hi, Das, what's his name? Hi, Karthik. E. Goldstein, Subarema. Who is the father of proton? E. Goldstein. And Newton? Who is the father of Newton? Let us know. Yes, my dear students, and Bohr, everything we know. But today, we discuss about electronic configuration. Students, electronic configuration difference. We write up to till what we write. First is in two cases. We include or we fill two electrons in L shell 8. But in K shell, we have subshell called 1s, 2s, p orbital, d orbital, everything is there. Structure of those orbital is there. This is very important. As my dear students, this is very important. Come on, let's discuss. Let's start with a basic sum. Students, before entering into the session, please do not forget to like, share, subscribe. I have one rule, right, students? Your Suhasar has one rules. What the rules? The video must and should be like. Right, my dear students? The video must and should be the likes cross minimum 50. Okay, come on, target it. Share the channel for your friends. Okay, students. S. Chadwick discover Newton. How we discover? After Goldstein, yes, my dear, not in Goldstein, Rutherford experiment, he discovered that he has some space. What happened? He find a mass of an atom except hydrogen, helium. According to it, what is the actual mass? It's 2. But whenever we weigh that one, it becomes 4. It's nothing but we have another extra particle. It is discovered by Chadwick. We already know it. No, right, students? Then come on, let's start with discovery of electron. In 1830, who is that one? Michael Faraday shows that if electricity is passed through a solution of an electrolyte, chemical reaction occurs at the electrodes. Who shows first electricity reaction? Michael Faraday. Michael Faraday laws is there. Right, my dear student? Faraday first law, second law in physics is there. Imagine, students, this is a physical chemistry chapter. Physical chemistry is nothing but physics is also there. Bye, Hema. It's not important for class 10. Sir, have you done cells part? No. Still, I am not done, Karthik. Whenever I have done the shells part, definitely I told you. In the end of the class, electronic shells part is done. Don't worry, in the end of the class, I explain everything related about cells, related about configuration, how to write electronic configuration, everything. Okay, Karthik? Okay, my dear student? No. Still it's not done. It still is not done. This about Michael Faraday laws and everything. We know, right, students? This is an cathode ray discharge tube. We know, right? What he do? He take one vacuum pipe, cathode and anode, and he takes some gas. and pass the electricity. What happened? Fluorescent glow is coming in the time of electron, right students? Fluorescent glow is coming. He called that ray as an cathode ray. He passed from cathode to anode and it consists negative charge, right my dear students? It consists negative charge and these particles are called as an electron. What is the symbol? How we represent electron, my dear students? E minus, right? Its charge is minus. Its mass is negligible because its charge is minus, right? That's why it's negligible. We are already familiar with that. This is an result of this experiment. This is a result. First, what he told, what he summarized what he summarized, students? What he summarized? First point, what he summarized? The cathode rays start from cathode and move towards the anode. Which ray? Cathode ray. Second one, these rays themselves are not visible, but their behavior can be observed with the help of certain kind of materials. It's not visible. These rays are there now. It's not visible, but we can easily observe that by using materials. If you by using which material? Fluorescence or phosphorescence, which glow. Whenever it bombarded with the wall of an, which wall? Where's that one? Yes. Whenever it moving, it bombard with the wall of a discharge tube and fluorescent glow is coming. By using that, we can easily told that, oh, here one ray is passing. It is bombarded with vacuum pipe or which is bombarded with which one? Discharge tube. That thing, he conclude that one. Second point, my dear students. Then after that, in the absence of electric or magnetic field, these rays travel in straight lines. In the absence. If we stop the electricity or if we stop the electric current, what happened? Completely broke this one. Then it forms in a straight line and they move in straight line. If we supply the electric charge, what happened? It is bombarded with the discharge tube. Okay, students, it's clear. This is a third point. Then after that, in the presence of electrical or magnetic field, the behavior of cathode rays are similar to that expected from negatively charged particles. If we pass the cathode ray in the presence of magnetic field, what happened? What happened? It deflects towards the negative plate. It deflects towards the negative plate and it passes towards the positive place. In the place of electricity, it passes or it moves towards the positive plate. Okay, students, it's clear. It deflects towards the positive plate. When electricity is happen, when we pass electricity or when we give electricity to the tray, what happened? It deflect towards the negative plate or it move towards the negative plate, my dear students. The last one, the characteristics of cathode rays do not depends upon the rationalized material. It's not depends upon anything, okay, of electrodes and the nature of the gas present in the cathode. Oh my god, it's not depends. Thus we can conclude that electrons are basic constituent of all the atoms. By using that, what we conclude? Electrons is there now. These are the basic stuff. Okay, students. This is a discovery of which one? Electron. Okay, it's clear. It's clear regarding about electron. Still, you guys have any doubts? Then let us know. Everybody, let us know in chat section. It's clear. Karthik and Anubhav and Nataraja. It's clear, students, regarding about electron. Very simple, student. Discharge tube. Simply pass some electricity. What happened? Cathode rays forming. This ray, whenever it bombarded with, how we identify this cathode rays? Whenever it bombarded, it show fluorescent glow. Very simple. And also, it consists of negative charged particles. How we conclude that one? It passes towards negative end to positive end. We know in the attractive place, what happened in the attractive side, in the attractive, what? Negative always attract to positive. By using that, he easily conclude that one. This about regarding about the electron. Next, move on to the charge to mass ratio. In 1897, who is the father of electron? Student J.J. Thomson. Measure the ratio of electric charge E to the mass of electron. He measured that one. E by ME. E by ME, right? Charge by charge to ratio mass. Sorry, charge to mass ratio. E by ME. M is nothing but mass of an electron. E is nothing but charge of an electron. Then using cathode ray tube and applying electric and magnetic field perpendicular to each other, as well as the path of electrons. When only electric field is applied, the electrons deviate from their path and hit the cathode ray tube at point A. What happened here? One diagram is there, right, students? Whenever we pass the cathode ray, what happened? It moved towards the anode thing, and only electric field is happened. It bombarded A side. It bombarded. Where it bombards, students? At exactly A point. Okay. Then only magnetic field is there. Yes, applied electric strike. S is done. And similarly, when only magnetic field is applied, electrons strike the cathode ray tube at point C. By carefully balancing the electric and magnetic field strength, it is possible to bring back the electrons to the path which is followed on in the absence of electric or magnetic field. What is the exact meaning, students? What happened? First, what he do? First, only he passed the cathode ray in the presence of electric field. What happened? In the time of electric field, it exactly bombarded at point A. And next what he do? Then he remove the electricity, and only he passed the cathode ray in the presence of magnetic field. In the presence of magnetic field, what happened? It completely bombarded at point C in the fluorescence globe. Okay, students, it's clear. Electricity presents. Whenever the electricity is there, it bombarded at A point. Whenever the magnetic field is present or magnetic field, it bombarded at point C. And what he do? He balanced both things. When he balanced both things, and he make a cathode ray to a straight line. By using this, he find the charge by mass ratio. Where is that one? Yes, here. Charge by mass ratio. Finally, he told that the charge by mass ratio E by mv value is given by 1.758820 into 10 power 11 coulomb per kg. Finally, he conclude 3 points here, students. First point, the magnitude of the negative charge on the particle greater the magnitude of the charge in a particle. Negative charge is there, na? It is always greater, he told that one. Then second one, the mass of the particle, lighter the particle, greater the deflection. If mass of the particle is lighter, then deflection is greater. Deflection is there, na? Electric field absent and magnetic field. Whenever the magnetic field is happen, the cathode ray deflect at the sum ratio and at the sum ratio. Okay. Similarly, if the particle is small, for example, let's consider hydrogen atom particles and carbon atom particle. If the hydrogen atom particles deflects at larger ratio, for example, hydrogen particle or deflects at this ratio around 90 degree or more than 80 or 70 degree. But whenever the carbon atom is there, that mass compared to hydrogen carbon mass is little bit high, right, my dear students? That's why it deflects a small angle. Very simple. Then third one, the strength of the electric or magnetic field. The deflection of electron from its original path increases with the increase in the voltage. If we increase the electric field or magnetic field, what happened? The deflection is there now. It also increases. Similarly, mass. What mass depends now? Mass is low, deflection is high. Similarly, electric charge, if we increase the voltage or the magnetic field, and also the deflection is high. Okay, my dear students. Next model, charge of electron. By who discovered charge of electron? R.A. Millikan. R.A. Millikan devised a method known as oil drop experiment in 1906 to 14. In 1906 to 14, he do this experiment and he confirmed the charge of electron. According to him, the mass by electron ratio, this one. Okay, my dear students. And this is a diagram. We already know that one. We already know this one. According to him, the charge of mass, the electron charge is -1. We already know relative charge and other things is there. We already discussed in class 9. It's very easy. Then next more the discovery of proton and neutron. Similarly, who discovered proton? E. Goldsmith. He also takes same discharge tube, but he had extra item. He had extra substance. Which substance he had? Mercury. He had mercury. What happened? Whenever he had mercury produced some positive charge rays. Those rays are called as Canal rays. Where is this? Here, canal rays carrying a positive charged particles. Canal rays carry positive charged particles. These positive charged particles are called as protons. These are the second, this is a second fundamental particle is present in atom. First one is electron, second one is proton, third one is neutron. Neutron is discovered by James Chadwick. Chadwick, he is a third scientist, or he is a father of neutron. This about entire proton, neutron and electron. It is very easy. And also we have few important points here. After he performed the experiment, he concluded these 3 points. First point is, unlike cathode rays, mass of positively charged particle depends upon the nature of gas. But here what happened? The mass is there now, it's completely depend upon the gas. Which gas we performing? For example, if you take helium gas and also carbon gas, we know, right students, compared to helium, carbon gas has high number of protons. Helium compared to carbon is low only. 2 number of protons, totally 2 protons are there in helium. In carbon place, totally 6 protons. Right, my dear students? It's completely depending upon gas. Then second one, the charge to mass ratio of the particles depends on the gas from which this originated. Mass by charge ratio also depends. As to be clear, sir. Thank you so much. Then third one, some of the positively charged particles carry a multiple of the fundamental unit. Oh my god, some of them are there now. They carry multiple charge. They carry positive also, negative also, neutral charge also. Okay students, this is about this one. And also here the property of fundamental particles of an atom. For electron, what is the symbol of electron, my dear student? If you know this table or if you learn this table, you can easily tell the entire fundamental property. And also students, you know one thing. In class 11, you have problems on chemistry, students, especially on this physical chemistry. In physical chemistry, for your examination, they ask problems. Sometimes they ask, find the charge of an electron, find the charge of a proton by using some fundamental property. They only give some given similar to the physics. Okay, my dear students. Okay, electron. What is the symbol of electron? E. Proton symbol P. Neutron represented by N. The absolute charge of an electron is minus 1.60 into 10 power minus 19. Proton, it's become positive. Neutron charge, there is no neutral charge is there. Neutron is nothing but neutral, 0. Then neutron relative charge is also 0. Relative charge of proton is plus 1. Electron is minus 1. Mass. The mass of an electron is given by this one, 9.1 into 10 power minus 31. That's why we always neglect the mass of an electron and also mass by U ratio. Right, students? Mass according to their atomic unit value. The relative mass of electron depends upon U value. Relative mass, what is the relative mass? 0.000. For this 1.007, 1.008. Almost these two are there now, students. These two relative mass, which one? Proton and neutron relative mass always same, always similar. Okay, my dear students, it's clear. Next, more are the models of an atom. So many scientists come, they told something about atom. They only imagine, right, my dear students? Who is the first scientist come to show the model of atom, my dear student? J.J. Thomson is a father of electron. We already know, right, students? First atomic model is plum pudding or watermelon model. What he told? He take an cake as an example. He take a Christmas cake as an example. We know, right, in cake what happened? In entire cake, the dry fruits are there now. They are arranged in middle time. And also take watermelon as an example. In watermelon, what happened? Entire red watermelon. Middle we have some black seed. Similarly, the black seed is there now. The black seed, he relate the black seed to an electron, and the positive, the red watermelon part is there now. They relate that things. They relate that things to what? They relate that things to proton. Okay, my dear students. Hi, Amit. What he do that? He explained entire Thomson model as a watermelon model. What he told that? Similarly, the entire red model is there now, students. Entire the red atom or the red fruit is there now. He relate the red fruit to a proton. He relate the red fruit to a proton, and the seeds are there now, black seed. They relate to electron. What he told here there? What he told? Yes, he told here. Rutherford Newton. Okay. Very simple, students. He told him something. An atom consists of a positive shaped sphere with the electron embedded on it. What he told? The atom consists positively shaped sphere, consists proton, positively shaped sphere of protons. What he told? Atom consists positively shaped sphere of protons with electrons embedded on it. It is a electron. It is a Thomson model. And also he told one important point here. What he told? Always the number of electron is always equal to number of proton. Number of electron is equal to number of proton, and atom is electrically neutral molecule or neutral particle. What he told? Atom is a electrically neutral particle. This is a first and important significant of Thomson atomic model. But this model is fails. Why? Why it fails? Due to Rutherford experiment, Rutherford alpha scattering experiment. What happened? Rutherford, new scientist, new fellow is coming. What he do that? He do one experiment. He takes some alpha particle, source of alpha particle, and he passes this alpha particle to an lead plate and to that gold foil. He passes it through a gold foil. Why he considered gold, students? We know, right? Gold is a most malleable metal. It's nothing but we can easily convert gold to a very thin sheet, right, my dear students? It's a most malleable metal. He take a gold thin foil sheet. It consists around 1000 atoms of gold, only 1000 atoms of gold. What happened? Whenever he passed the alpha particle is nothing but the alpha particle have +2 charge and 4 atomic mass. It is nothing but whenever we remove 2 electron from helium atom, it become alpha particle. Is nothing but helium 2 plus element. Alpha particle is nothing but whenever we remove 2 electron from helium element. Here is valence shell. What is the electronic configuration? Is 2, right? It is duplet configuration. If we remove these 2 electrons from its valence shell, what happened? It only become alpha particle. Alpha particle is nothing but it is a particle consists 4 atomic mass unit and +2 charge. Okay, my dear students. What happened? Look here this diagram. Whenever he passed the alpha particle, most of the alpha particle passes straight line. Most of them are passes straight line, and most of them are deflected towards the same path and towards 90 degree and other things. From using this, he concludes some points here. First point is most of the alpha particle passes through the gold foil undeflected. Is nothing but in atom there is a what he conclude that without any deflection some alpha particle, most of the alpha particles are passing. He told that in atom we have free space or empty space. In atom, empty space is present, he told that one, and a small fraction of the alpha particle was deflected by small angles. And third point, a very few alpha particles, 1 in 20,000 alpha particle, only one, approximately 1 alpha particle bounced back. That is where deflected nearly 180 degree. Which path is coming now? Same path is bounced back, my dear students. On the basis of this observation, he concludes some points. What? Most of the space in the atom is empty. I already told that one. Because most of the alpha particle passes through straight line only, right? Without deflection, it passes. Undeflected, right? Undeflected, it is passed. From using this, he told one thing. Atom is empty. Most of the part of atom is empty, he told that one. And a few positively charged alpha particles were deflected. The deflection must be due to enormous repulsive force showing that the positive charge. It is deflected. because something is there on that. If it's deflected is happened, then this is also a positive charge only. He told that one. And also calculation by Rutherford showed that the volume occupied by the nucleus is negligibly small. And also he told that one, that path, that mass is there now. Some mass is there now. Due to deflection, some mass is there now. This mass he called as a neutron. Not a neutron. Sorry for that. Nucleus. Nucleus is nothing but positive charged space or positive charged mass. Okay. This way the nucleus is discovered. Who discovered nucleus? Rutherford only. For this experiment, he got Nobel Prize also, students. Okay, this about this one. And also, he compared this to a cricket ball representing a nucleus, then the radius of atom would be about 5 kilometers. What he told? He identified nucleus, right? That positively charged sphere, and the small space is there now. That positively charged space he identified, right? This nucleus. But what he told? He compared this to an cricket ball, and other atom size is there now. To an 5 kilometer is nothing but compared to radius of an atom, this nucleus radius is very small. What he conclude? The nucleus size is there now, or the nucleus size or nucleus radii, it is very small compared to the atom radii. Okay, compared to atom radii, it is very small. He told like that, students. Okay, it's clear. Then after this, on the basis of the experiment, Rutherford proposed the nuclear model of an atom. What is the name of Rutherford model? Nuclear model, my dear student. J.J. Thomson model is called as a plum pudding model. Rutherford model, nuclear model. First point. First postulate of this model is the positive charge and most of the mass of the atom was densely concentrated in extremely small region. The positive charge in atoms, some positive charge is there now. It's called as a nucleus. It's called a nucleus. It's completely small size. Overall positive charge, it is completely concentrate on the small size. It's nothing but overall positive charge. It's only there in this small size. This small size molecule or the small size space is called as a nucleus. It is called as a nucleus. Okay. This very small portion of the atom was called nucleus. Yes, I explained now only. This small space is there in a small portion. In this small portion, entire positive charge. It is nothing but proton. Entire proton is present in this small portion only. This portion, what we call nucleus, he called as a nucleus. Very, very difficult chapter, students. Really, it is very difficult. But if you understand the concept, if you relate the concept, it is very easy. Okay, don't worry. I give some trick in end of the session. Please watch the video. In end of the session, I give some trick. Definitely, it is very useful, guys. If you know this trick, you can easily score out of 4 in this unit. It is very important and it is also one of the toughest chapter, my dear students. But not tough as like organic. Organic is a toughest subject. Okay. Okay, my dear students. Then second one, the nucleus is surrounded by electrons that moves around the nucleus with a very high speed. What happened? Electron is there now. What happened? These electrons move towards this nucleus with high speed. High speed, it revolving around the nucleus with a certain orbit. This orbit are called as a electron orbit. He relate orbit, such an orbit. This path this path he called as a orbit. Thus, Rutherford model of an atom resembles the solar system in which the nucleus plays the role of sun and the electrons the revolving planets. He relate the Rutherford model to a solar system. What happened in the solar system, my dear student? Sun is placed in center and other orbits are there now. Oh, sorry, other not an orbit, sorry for that. Other planets are revolving around sun. We already know, right, that one solar system. Similarly, nucleus is center, then the electrons revolves around the nucleus in certain path. This path he called as an orbit. Okay, my dear students. This about Rutherford model. Here we have few important terminologies. What is atomic number and mass number? Let us know in chat section, everybody. Amit, Surabhi, what is atomic number, my dear student? It is denoted by symbol Z. Atomic number is nothing but total number of proton present in an atom. Total number of proton present in an atom. What is atomic mass or mass number? It is denoted by A. It is nothing but total number of proton plus neutron. But in the case of mass, we neglect the mass of electron. We neglect the mass of electron. Why? Because it is negative, right? That's why we neglect the thing. Okay, students. And what is isotope? Isotope, students, these two are very important. Isotopes is nothing but same element. Same element has same atomic number but different atomic mass. Same Z value, different atomic mass. For example, hydrogen proton. Hydrogen isotopes. Proton, deuterium, and tritium. Right, my dear students? Isotopes is nothing but same atomic number but different atomic mass. Same atomic number, different atomic mass of a same element. But isobars is nothing but isobars. What is isobars? Different element has same atomic mass but different atomic number. Sorry, is that right? Atomic number. This is called isobars isotopes. Isobars example, calcium and argon, right? Both have 40 atomic mass but different number of protons. 18 and calcium is 20, right? Calcium and example is calcium and argon. It is also 40, it is also 40. This one is 18, this one is 20. Right, my dear students? We already know, right? Notation and everything. We write atomic mass in this side and atomic number in this side. Right, my dear students? Sorry, atomic mass in this side. Right? This is notation. We all know about these basic concepts. Then move on to the drawbacks of Rutherford model. He told something, right, students? What he told? Nucleus is there. The electrons revolving around the nucleus in certain path. What happened? On the same time, Maxwell is come. Not a Glenn Maxwell. He is different Maxwell. Both's name is Maxwell. Right, my dear students? Not a Glenn Maxwell. He is a RCB player and Australia player right now. Yes, my dear students. Today RCB match is there. RCB versus Mumbai match. Right, my dear students? Glenn Maxwell, not a Glenn Maxwell. Maxwell. What he told? Any particles is revolving around certain orbit. What happened? It loses energy or it radiates energy and after some time it fall down. That is the main drawback of a Rutherford atomic model. What is the main drawback? Any particle, I write here, please note down this point, my dear students. Any particle revolving around any particles revolving around a circle or the circular path, it radiates energy or it radiates energy. Not radius, it radiates energy and after some time it's fall down. Okay, my dear students. Hello sir, after a long time I am watching your session. Hi Dabi. Yes, after a long time. Yes Dabi. Dabi, now you are class 10, right? You are at class 10, don't worry. I already complete entire foundation class, Dabi. Class 10 entire foundation class. Please watch those videos. I already complete chemical reaction, entire thing. Please watch this. Okay. This is a main drawback of Rutherford model, students. Then after that, this drawback or this failure is leading to develop a Bohr's model. Okay. Which is the exact reason to develop or leading to develop the Bohr's atomic model is these two. The first one is dual character of electromagnetic radiation. We don't know about electromagnetic radiation, my dear students. Hi Arun. Hi, good evening. Oh, not a good evening. Good afternoon. Good afternoon, my dear students. Okay, it's done, my dear students. Sorry for the students. First one is dual character of electromagnetic radiation, which means that radiation possesses both wave and particle-like property. Both wave is nothing but sine wave, right, students? Task, crash, and wavelength, wave number. Sir Divya, yeah, I know, Divya. Sorry for that. I know. I don't think it's nothing but Divya. On the day, I told correct name only, right? In GOC time, I told you, I asked you correct name only. No, no, no. I told you correct name, but today I forgot. Sorry, ma, Divya. Hi, Divya. Then experiment results regarding atomic spectra. What is spectroscopy? It is very important technique, my dear students. Spectroscopy, you know one thing. You are Suhas sir, do some extra specialized class. Yeah, he completed. Me completed extra specialized class related to spectroscopy topic. Okay, it is very important. These are the two developments leading to the Bohr's atomic model. We already know. Next, more on the wave nature of electromagnetic radiation, students. Before entering to the wave electromagnetic radiation or wave nature, let's take 5 minutes break, my dear students. Let's take 5 minutes break. Okay, the sessions continue at exactly S19 is there 1:14 p.m. 1:14 or 1:15. The session is continue at 1:50. Okay, I'm back. Students, I'm back. Don't go anywhere. Go and have some tea and come back. Yes, students. Oh, thank you so much, Divya. Thank you so much for your beautiful comment. Thank you so much for your beautiful review. Thank you so much, students. Thank you so much. Without you guys, I cannot tell the thing. Without you, I am not here. Okay? With from you, from your support only, your Suhas sir grow like this, students. Thank you so much for your support and love. Please give some more support for class 11th and class 12 students. Okay, some more support for class 11th and class 12 organic chemistry topics. Okay, come attend the live session, ask doubt session with your Suhas sir, and if you have any doubt regarding about any subject, then let us know. Oh, sorry, any subject not regarding about organic chemistry and another one mathematics. Okay, you can ask any doubt, students. But physical chemistry, I think physical chemistry is taken by other teacher because I am organic specialized teacher. Okay, students, this is about wave nature. Come on, let's discuss wave nature of electromagnetic radiation. Students, whenever you enter class 11 and class 12, from class 10 only, I told you guys, students, focus on NCERT, it is very important. Focus on solving NCERT solutions, it is very important. If you have any doubt in NCERT solutions part, then follow this channel, students. The channel name is NCERT solution for class 11th and class 12th by Vedantu. In the channel, on the channel, your Suhas sir teaching entire organic part. Totally, I teach 5 units, students. Watch that unit and give some feedback in that unit. Okay, watch that video and give some feedback on that video, not in video. Okay, students, come on, let's discuss wave nature of electromagnetic radiation. In the mid 19th century, is nothing but approximately 1950. Hey, not man, mid 19th is nothing but 500. Oh my god, 19th, is this, no, 1950 only, correct, 1950. What happened? Physicists actively studied absorption and emission of radiation by heated objects. What happened? He heated, the physicist there na, physics scientist, some scientists make a group and heated some compounds and they studied the absorption spectra and emission spectra. If we heat the compound, it emits some heat energy, right? How it emitted, how it absorbed the heat. They studied like this. Okay, students, and they made some. It is now well known fact that thermal radiation consists of electromagnetic waves of various frequency of wavelengths. Heat is nothing but thermal reactions. If we use the heat in that reaction, when we call that reaction as a thermal reaction, we are already familiar with one, right, my dear students? Similarly, now they called what they called the thermal radiations, or they all releases or absorb the electromagnetic waves. Both are same. Thermal radiation also include the electromagnetic waves. They told like that, students. Then after that, what they told, which were unknown in the mid 19th century, first active study of thermal radiation laws occurred in the 1850, and the theory of electromagnetic waves and the emission of such waves by accelerating charged particles was developed in the early 1870. It is developed in early 1870 only, my dear students. Who discovered this electromagnetic radiation theory? James Clerk Maxwell. Maxwell discovered electromagnetic radiation theory, which was experimentally confirmed later by Heinrich Hertz, not an Heinrich Claassen. Heinrich Hertz. It is experimentally confirmed by the scientist who is the experimentally confirmed the electromagnetic radiation theory. Heinrich Hertz. Heinrich Hertz is the scientist. He confirms experimentally regarding about electromagnetic radiation. Okay, my dear students, here we will learn some facts about electromagnetic radiation. James Maxwell at 1870 was the first to give a comprehensive explanation about the interaction between the charged bodies and the behavior of electrical and magnetic field. What we sorry for the students, what he relates, charged body, either it is positively charged, either it is negatively charged. He relates the charged body to electric field and magnetic field. Who relates that one? James Maxwell. Behavior of macroscopic level. He relates that in macroscopic, not a microscopic. Macroscopic is nothing but it is visible to our eye. Our naked eye, it is visible. It related that one. He relates that one. Okay, my dear students. He suggests that when electrically charged particle moves under acceleration, alternating electrical and magnetic fields are produced and transmitted. What he told? When an electrically charged particle is there, it is nothing but negatively charged particle. If we moves, the same particle moves under electric field and magnetic field, it is also releases some electric field, or it is also produce some electric field and magnetic field. Students, very difficult chapter. I repeat once, students, if you still have doubt, then let us know in chat section. My dear students, very important. What he told, same Maxwell, what he told, some electric charged particle is there now, some electric charged body. Imagine I am an electric charged body. Whenever I move, I am producing what? Entire magnetic field, also entire magnetic field, and also electric field. But actually, what the other scientists believe, in only presence of electric field and magnetic field, the charged body is moving. But what happened? Charged body, if any charged body is moved, it is also produce some electric field and magnetic field. Who clarify about this enrich us from experimentally he clarify this thing. But who told this one? Maxwell is told this one. Okay, students, it's clear. This waves called electromagnetic waves or electromagnetic radiation. What is electromagnetic radiation? These are the waves produced by charged particle. These are the waves produced by charged particles. In this rays or in this waves, it consists both electromagnetic and also it consists both electric and magnetic fields. What he concludes, finally, students, charged body, charged particle, if charged particle is moving, it's also produce magnetic field and electric field. And also he concludes something. What he conclude? These rays are called as electromagnetic radiation rays. That's why it has both nature, wave nature and also particle nature. Particle nature is nothing but it is a charged body. Wave nature is nothing but it transmitted. That is called electromagnetic waves. Light is the form of radiation known from early days, and speculation about its nature dates back to remote ancient times. In the ancient time only they told that light is a form of a wave. Light move in the form of wave. It's nothing but in sine wave format. In some, we have different type of wave. Students, in chemistry, you mainly focus on this sine wave. It's move towards on this direction. And also you guys know about the electron shift from one lower energy levels to another higher energy levels, or high energy levels also very important in this unit. Okay, my dear students, Maxwell has assigned the first to reveal that light waves are associated with oscillating electrical and magnetic character. Light wave also associate both magnetic and electric character. It is a dual nature. Light also dual nature. Why light wave always called dual nature? Because it also produce some. Whenever light also consists some charged body, right, my dear students? Whenever the light is moving towards one place to another place, it's also produce some electric field and magnetic field. Who told it? Who associate this one? Who told this? Maxwell told this thing. But he is not proved any experimentally. He is not proved this statement by experimentally, but his student, Heinrich Hertz, the another scientist is come, Heinrich Hertz, he proved experimentally. This is a dual nature of electromagnetic radiation, students. Then although electromagnetic wave motion is complex in nature, we will consider here only few simple properties. In this we have consist only few important properties. Totally how many properties are there? Totally 4 properties. First one is the oscillating electric and magnetic field produced by oscillating charged particles are perpendicular to each other. Both are perpendicular to the direction of propagation of the wave. Simplified picture of electromagnetic wave is shown in figure 2.6. Where is that one figure? Yes, here. This is not a figure. I think it's forgot. Okay, students. First point. What is the first point? The oscillating electric and magnetic field is there now. The magnetic field and electric field, they are perpendicular to both each other. If electric field is moved towards on this direction from left to right, then magnetic field is exactly perpendicular to electric field. He told the first point. What is the first point? Electric field and magnetic field are perpendicular to each other. Okay, second one. Unlike sound waves or waves produced in water, electromagnetic waves do not require medium and can move in vacuum. It's nothing but what he told. Waves. For waves in water and other waves in sound, we need some source of energy, right? For in water, how wave is produced in water? If we throw some stone to a water, it produces wave. If we throw some stone to a water, it produces some waves. Similarly in sound also. If we beat that object, then it produces sound. But it's not like that. Without any energy or without any vacuum, it is forming. This wave is there now, the light wave. Without vacuum, also forming. Because, okay, students, not a because, sorry for that. For example, you know, right? What we talk, it is also move towards in the form of sine wave only, right? For example, in classroom, what happened? The lecturer is explaining the concept. Some students are sitting last bench. The sound, the transfer of the voice is not same for both first bench and last bench students. For first bench students, the listening capacity or the voice is there now. It is high compared to last bench. Similarly, this thing is happened. Third point, it is now well established that there are many types of electromagnetic radiation which differ from one another in wavelength. We have many type of electromagnetic radiation depends upon their wavelength. Okay, students, this spectra, this constitute what is called electromagnetic spectrum. This is called as an electromagnetic spectrum. Fourth point, different kinds of units are used to represent electromagnetic radiation. We use different units. These radiations are characterized by the property, namely frequency and wavelength. We have mainly used these two units to represent electromagnetic radiation. Which of those? Frequency, either we represent in frequency or wavelength. Frequency, the corresponding symbol is mu. Mu is nothing but frequency. Lambda is nothing but wavelength. Reverse form of Y. Right, my dear students? The SI unit of frequency is V is Hertz. Frequency SI unit is Hertz per second or Hertz or sec per second. After enriched Hertz, it is defined as the number of waves that pass given point in 1 second. Before Hertz, after enriched performed experiment and he conclude and he proved that experiment, right, students, and he proved the Maxwell explanation regarding about the dual nature. On that time, enriched Hertz gives the Hertz as a SI unit and also per second. He told the wavelength as it is defined as the number of waves that pass per second in a given point in 1 second. In 1 second, how many waves are produced now? This is called a Hertz or wavelength. These waves are called a wavelength. Who told that? Enriched. Wavelengths should have the units of length, and you know that the SI unit of length is the meter. Since electromagnetic radiation consists of different kinds of wave of much smaller wavelength, smaller units are used. Figure 2.7, this we have done. In figure 2.7, we have type of radiation and everything is there. It is regarding about lambda 10 power minus 16 something is there. This is a visible spectrum. Okay, 400 to 750. Gamma rays, no. Yes, gamma, X-rays, UV, IR, microwave, FM, AM. These are all called as a radio wave and long radio waves. These many electromagnetic radiation are there. Totally how many types are there? Totally 3, 4, 5, 6, 7 type of EMR. 7 type of electromagnetic radiations are there. This is a visible spectrum. It is nothing but what we visible now. This wavelength. For example, some people use some specs to visible something because the specs adjust between these wavelengths 400 to 750. This wavelength is there now. This is called visible spectrum. Okay, my dear students, it's clear. I hope it's clear. It is really difficult, students. Students, from this unit, let's discuss the first important problem here. This unit is nothing but problem. Physical chemistry is nothing but problem, right? Physics is nothing but problem is there. Similarly, in physical chemistry also problem is there. It is very important. Please focus on problems, my dear students. Here the first problem is the other. Okay. The Vivid Bharati station of All India Radio Delhi broadcast on a frequency of 1368 kilohertz. How many? What is the frequency here? Frequency value is 1368 kilohertz. Calculate the wavelength of the electromagnetic radiation emitted by transmitter. Which part of the electromagnetic spectrum does it belong to? They give lambda value. What is lambda? C by V. C is nothing but speed of light. Okay, students. V is nothing but frequency. They give frequency. What is the speed of light? 3 to 10 power 8, right, students? Then simply apply this. Then you got the lambda value. Very important. 3 marks, definitely one problem is coming from this unit. For your JEE also, for your JEE question, NEET question, especially from this unit, from this physical chemistry, they ask problems. They ask problems, not any theory concepts. To solve the problem, the theory concept is very important, my dear students. Next, move on to the particle nature of electromagnetic radiation or Planck's quantum theory. Very, very important. You know one thing, students. When I was studying class 11, same theory is there, same unit, nothing changes, students. In before 6 years also, not before 6 years, once again 2018. Yes, before 6 years. Yes. I complete my PU in 2018. In before 7 years, sorry, first PU is nothing but 7 years, okay, 2017. I started my 2016 to 18, 2017, I write my first PU exam. On those year also, same unit is there, same line, everything is same. Okay, students, Planck's quantum theory. According to this theory, the nature of emission of radiation from odd bodies, ejection of electrons from metal surface when radiation strikes it, photoelectric effect, black body radiation, variation of heat capacity of solid as function of temperature. He told few points here. Planck's quantum theory, some of the experimental phenomena such as diffraction and interference. Diffraction, what is the meaning of diffraction and interference? Let us know in comment section, my dear students. This is homework question for you guys. What is the meaning of diffraction and interference? You already studied, right? You already studied these 2 points in your class 10th physics, right, my dear students? If you know the 2 concepts, then let us know in comment section. If you don't know, don't worry. In next class, I explain those 2 concepts. Can be explained by the wave nature of the electromagnetic radiation. However, following are some of the observations. These are the Planck quantum theory observation. What he told, first point, the nature of emission of radiation from the odd bodies. What he told, black body also radiates some energy. Second one, ejection of electron from metal surface when radiation strike it. It is called photoelectric effect. What happened when metal ejected or strikes some electrons, whenever it strikes to metal surface, what happened? It radiates energy. This effect is called photoelectric effect. Third point, variation of heat capacity of solid as a function of temperature. If we varies the electricity, what happened? It is also one of the function of temperature. Heat capacity also function of temperature, he told that one. And that fourth one, line spectra of atoms with reference to hydrogen. Always we refer hydrogen spectra for all atoms. Sorry, students. Okay. These phenomena indicate the system can take energy only to discrete amount. All possible energies cannot be taken or radiated. Okay, students. This unit is entire theory unit, students. Next, who is this Max Planck? Max Planck is a German physicist. Received his PhD in theoretical physics from the University of Munich in 1879. In 1888, he was appointed director of the Institute of Theoretical Physics at the University of Berlin. He is German physicist. He is not a chemist. He is a German physicist. Okay. Then Planck was awarded the Nobel Prize in Physics in 1918. He awarded Nobel Prize in 1918. Okay, students. Next, what is the photoelectric effect? What is photoelectric effect? In before exercise in the quantum theory we discussed, right? What happened? Ejection of electron, or whenever the electron strike to a metal surface, it produces some effect. This effect is called photoelectric effect. We already know, right? In 1887, Heinrich Hertz performed a very interesting experiment in which electrons were ejected when certain metals were exposed to a beam of light as shown in figure 2.9. Where is that figure? Oh, figure is not there. Sorry for that. This phenomenon is called photoelectric effect. What happened? Metal ejects some electrons, right, students? Sorry for that. It's not any bombarded. Here, if we bombard something, then metal ejected some electron, then the ejected electron is bombarded with the light. What happened? Same, right? Yes. Elected were exposed to a beam of light. The electron, what we do? Metals ejected some electron. Why, students? Metal? Due to attain electron, to attain what? That's one. Sorry for that. Wait 1 second. Yes. Okay. What happened when you bombard something to a metal? It ejects electron. Why? To attain electronic configuration of noble gas, right, students? To stabilize it donates electron or it transmitted electron or it eject electron. What he do? Same electron he bombarded with a light and it shows some spectra. This effect he called photoelectric effect. This phenomena, what he called this phenomena, photoelectric effect. I explain once, students. I explain another time. Please focusing on it. Please focus on it. What he do? What he do, students? He do one thing. He ejects some electron. He do some bombarding a metal, and that metal eject. The metal releases some electron. Same electron he bombard with a light. This phenomena is called photoelectric effect. These are the three important points by using this effect. The results of this experiment. The first point is the electron are ejected from the metal surface as soon as the beam of light strike the surface. The electron ejected from the metal is there na. It's soon it moved fast and soon it bombarded with light. Second point, the number of electrons ejected is proportional to the intensity of brightness. The number of electron ejected is there na. It is directly proportional to the brightness of the light. Brightness is there na of light. For each metal, there is characteristic minimum frequency is there. This is called threshold frequency. What is threshold frequency? For each metal, there is a characteristic minimum frequency. What is threshold frequency? Very important. Please mark that one. This about who? Hertz experiment. Next, more the who is Albert Einstein is coming of electron ejected does depends upon the V, something is happened. Then more the dual behavior of electromagnetic radiation, and after that problem. Okay, after this problem, then evidence for the quantized electronic energy levels, atomic spectra. Next more the spectrum topic and the line spectrum of hydrogen. After that, what the line spectrum, then Bohr's model, very important. Bohr's model, then Bohr's regarding about limitation Bohr's model and towards quantum theory and everything is there, shapes, and the last slide. Still we have so much concept, students. Then this one is done. Then dual behavior of electromagnetic radiation. Come on, let's continue the dual behavior of electromagnetic radiation, my dear students. Here, the particle nature of light poses a dilemma for scientists. On the one hand, it could explain the black body radiation and photoelectric effect satisfactorily, but on the other hand, it was not consistent with the known wave behavior of light, which could account for the phenomena of interference and diffraction. This is a phenomena, black body radiation, students. Okay, the only way to resolve the dilemma was to accept the idea that light possesses both particle and wave-like. Why they accept this one? Because due to black body radiation experiment. Finally, all scientists accept the fact. What they accept? What they accept, students? Light possesses both behavior, both form or both behavior. It acts as both particle and wave-like property. That is, light has dual behavior. Finally, they accept that thing due to Earth's experiment. Okay, this thing about dual behavior. Then after that, your own problem is there. Very important problem, my dear students. Focus on it. Focus here. Do focus here for 5 seconds. The problem is very simple. Calculate energy of one molecule of photon of radiation whose frequency. They give frequency. We know energy is equal to h nu. E is equal to h nu. They give h value. H is equal to, we know h value, Planck's constant. 626 into 10 power minus 24. Then frequency, they only give that one. Frequency 5 into 10 power 14 hertz or per second. Both are same. Then multiply these two. Then write the answer. This is energy. This is energy, but energy of one photon. Energy of one photon is nothing but we need to multiply. We need to multiply again with what? Again with Planck's constant value. Then you got the answer. No, not Planck's constant. 1 mole of photon. What is the charge of 1 mole of photon? This one. Then you got the answer. Very simple. I explain on, students. Here they give frequency value. First we need to find out the energy. We know E is equal to h nu. By using this relation, find the energy value. Then after this, simply do that. We know energy. Here we need to find out the 1 mole of photon. What is the charge of 1 mole of photon, or what is the relative mass? The relative mass is this one, 6.022. Then you got the answer. Very simple. Okay, my dear students, this is a charge or the energy of the photon. It's done. Now it's done, students. Any doubt here? If you have doubt, let us know. Next mode, the 2.3.3, evidence for the quantized electric energy levels, atomic spectra. Evidence. What is the evidence behind the atomic spectra or any relevant topic about spectrum? What is spectrum? A ray of white light spread out in a series of colored bands is called spectrum. White ray is there now. It's bombarded with some particles and produce some color of spectrum. Color of waves. This waves is called spectrum, my dear students. Then continuous spectrum is there, something is there. Here, emission and absorption spectra, very important topic. The spectrum of radiation emitted by a substance that has absorbed energy is called emission spectrum. What is emission spectrum? The spectrum is there now, the spectrum of radiation. Some particle radiates some energy which is emitted by a substance. Same. This energy is emitted by a substance that was absorbed energy. It absorbs some energy. This ray is there now. What the radiation is produced by source or energy or the particle is there now. This ray is absorbs some energy. What happened? It absorbs some energy. This energy is called emission spectrum. Atoms, molecules or ions that have absorbed radiation are said to be excited. These are exciting. Same like you guys. Whenever we start session, you are always excited, right, students? Similarly, it's happened like this. To produce an emission spectra, energy is supplied to a sample by heating or irradiating it, and the wavelength of the radiation emitted. To produce this, we need to supply some energy. This is a concept, very simple. To produce energy, we need to supply some concept, and it emits some energy. This energy which absorbs the spectra, this is called emission spectra. Which absorbs is there now, this is called emission. It's nothing but the energy is emitted. That is very simple. The particle is emitted in this one. This is called emission spectra and it is very excited. Okay. Then here one important point is there. Please note down this point. The study of emission or absorption spectra is referred to as spectroscopy. Here we have different type of spectroscopy, line spectra or atomic spectra, line emission spectra, everything is there. Spectroscopy is nothing but the study. It is a study of emission or absorption spectra. For example, if you give some energy to any particle, it emits something. In this radiation, what happened? This radiation absorbs energy. That's why it is called emission spectra. Okay. Similarly, we give some energy, right? This is called absorption. This is called emission. This is called absorption. Don't confuse student, absorption, emission. Okay. After that, this study is there, the entire study is called spectroscopy. Always we know, students, always we take a reference. We take hydrogen spectra as a reference for all other spectra because hydrogen is very smallest element. Right? In the periodic table, hydrogen is very smallest element. We know that, right, students? Now, next mode of the line spectra of hydrogen. When an electric discharge is passed through gaseous hydrogen, the H2 molecule dissociate and the energetically excited hydrogen atoms. We already know in J terms what Goldsmith experiment, right, my dear students? Balmer showed in 1885 on the basis of experiment observation. He shows some experimental observation. What that its spectral lines are expressed in terms of wave number. Spectral lines is always represented in terms of wave number, my dear students. This is a formula. Wave number is equal to 109.109,677 1 by 2 power n minus 1 by n square. N is equal to, is a integer equal or greater than 3. It is always greater than 3, my dear students. This series of lines described by the formula are called Balmer series. Which is the Balmer series? This formula is called Balmer series. The Balmer series of lines are the only lines in the hydrogen spectrum which appear in the visible region of the EMR. This series only, it is appear in visible region. It's nothing but 400 to 800 nanometer. Okay. This is also called UV spectroscopy. Okay, students. Then this is called Rydberg constant is also there. The value, this value is called it is called as an Rydberg constant. What is Rydberg constant? In Balmer's formulae, 109,677. This value is called Rydberg constant for hydrogen. The first 5 series of lines are correspond to this value. N, if N1 value is equal to 1, N2 value 2, 3, it is called ultraviolet. They spectra appear in ultraviolet region and visible IR region. Okay, this series are called Lyman. Balmer series always appear in visible region. Paston series it is always appear in infrared. Bracket series it is always appear in infrared. Fund series also appear in infrared series only. Okay, students, it's done. Then this is a schematic representation of spectra. This is energy and this is wave number. Okay, if n value is this one, Paston series or appear here, Balmer series in this one, Lime series it is appear in ultraviolet, visible and IR. Okay, in IR series or that one infrared series. Okay, done. Next model, the Bohr model of an hydrogen atom. Bohr model, students. Before entering to the Bohr model, what's the exact time now? Hi, Drusti. Students, really it is one of the toughest chapters, students. Don't worry, please note down this unit. Okay, if you still have confused, I explain once. Okay, it is difficult to mine also because I am basically organic chemistry teacher, students. I don't know pure knowledge about physical. Okay, don't worry, I explain it. Don't worry, I explain another time also. After every unit done, after the series done, the foundation series, after this series, I explain once again also. Okay, students, let's take lunch break, my dear students. Lunch break till 2:15. Lunch break now till 2:15. Let's connect at 2:15. Okay, let's continue the session at 2:15. I have studied in class 10. Class 9, super, nail Bohr. Yes. In class 9, we have nail Bohr atomic model, right, my dear students? Okay, let's continue the session at exactly 2:15. Okay, don't go anywhere, go and have some lunch and come back. Okay, my dear students, I'm back within 15 minutes. Yes, students. Hi. Hi, sir. Happy afternoon. You call me a stopper, sir. Okay. Hi, David, sir. Oh, stopper. Hi, Sampan. How are you, sir? I'm good. How are you? Hi, Mahalakshmi. Everybody, I sorry for that, students. So due to some discussion, the class is slated. Students, you have one big surprise reveal on Monday in Diksha Vedantu channel. Okay, in Diksha Vedantu Kannada channel, you have big surprise reveal, students. We are planning to start NEET and cases classes. Stay with us and join the live session at exactly on Monday, students. Regarding about the channel name is Diksha Vedantu Kannada channel. Subscribe the channel, okay? Not Diksha Karnataka channel, Diksha Vedantu Kannada channel. Okay, my dear students. Hi, Sen. Hi, Sampan. I saw your comment. I saw your comment on metals and non-metals video. Don't worry, I do that unit. I do entire periodic classification unit, students unit for foundation class. Okay. Happy, all of you happy for the. Yes, students. Then move on to the frequency. How to find out frequency by using this formula? The frequency of radiation absorbed or emitted. We know, right? Any charged particle radiates some energy or absorbs some energy. Before radiating, we supply some energy to radiate the energy. What here we do, student? Simply we supply energy. Then the compound gains that energy, the compound absorbs that energy, same energy the compound emitted. This is a phenomena behind entire structure of atom or entire particle, charged particle. What happened? The particle is there now. They absorb some energy. And similarly, in the same case only, they release some energy, students. They absorb and they release. Okay, my dear students. Here, the N value, the energy, the difference in energy is given by this formula. Del E is nothing but higher energy level to lower energy. What happened in the case of absorption? Absorption, what happened? The energy is there now. The electron present in lower energy is jumped to an higher energy in the case of absorption. In the case of emission, what happened? Same electron jumps from higher energy to lower energy. This is called del E. Either jumping or either losing. Very important, students. I repeat once. What happened when we supply energy? Same electron jump from lower energy to higher energy state. Similarly, same case when the emission process, same electron jumps from higher energy to lower energy. Okay, student, it's clear. Where E1 and E2 are the energies of lower and higher allowed energy states respectively. This expression is commonly known as Bohr frequency rule. What is Bohr frequency rule? Sorry, Bohr's frequency rule. I repeat once, what is Bohr's frequency rule? Very important, students. When energies is there now, the electron jump from lower energies to higher energy. In the case of whenever we supply energy, what happened? The electron is there now. They jump from lower energy state to higher energy. What it do? Lower energy state to higher energy. I repeat once, lower energy to higher energy. This thing is happened, my dear students. This frequency rule is called Bohr frequency rule. Bohr frequency rule, the relevant formula is this one. The N Bohr frequency rule is given by del E by H formula. Del E is nothing but E2 minus E1. Okay. Del E is equal to E2 minus E1. The difference between two energy levels. Okay, students, is clear. Then the angular moment of an electron is quantized. Quantity is nothing but is entirely quantized. The angular moment is there now. It is entirely quantized. It's given by this formula. MVR is equal to N into H by 2 pi. Where N is equal to 1, 2, 3. Energy levels. N is nothing but energy levels, students. The angular moment, entire angular moment is quantized, sir. Then the formula is given by angular moment. I think Neha ma'am, she has already explained this concept, angular moment concept, right, my dear students? It is given by N into H by 2 pi. N into H by 2 pi. Where ME is the mass of electron. ME relevant to mass of electron. V is the velocity and R is the radius. I hope it's clear, my dear students. Then who is this fellow? Niels Bohr. Niels Bohr atomic model. We already know, right, students? Sir, when is the 10th class? Mahalakshmi, 10th class almost is over. It's almost, I completed entire 10th syllabus, chemistry 10th syllabus, and I have planned to take maths classes, 10th maths classes from the date Monday. Oh, what's the date today? Today is 11, right? From the date 15 onwards, I take entire class 10th maths syllabus. Okay, I start entire class 10th math syllabus from the unit real numbers. I start with real numbers lecture 1. Okay, Mahalakshmi. At exactly 15. At exactly 15, I start maths classes. Okay, I start maths classes. Okay, further? Yes, super. Who is Niels Bohr? Niels Bohr is also a Danish physicist. Received his PhD from the University of Copenhagen in 1911. He then spent a year. Oh my God! He spent a year with J.J. Thomson and also Hans Rutherford in England in 1913. Bohr is there na? He is a friend of both Johnson and Rutherford. These three fellows or make a one group and discuss something. And discovery, they discover the atomic model. First, J.J. Thomson discovers something, and second fellow is coming, who is Rutherford. He discovers something electron. He proposed some model about atom, and also then after that this Niels Bohr is coming. You know, students, this theory also fails. This theory also fails because this is an Rn. How to find out radiation? Energy of a electron or the atom is given by this formula. Energy En is equal to minus 2.18 into 10 power minus 18. Similarly, Rn. Radii of an electron or radii, sorry, not an electron, of an atom, students. Radii of an atom is important. Radii of an electron is not important. Radii of an atom is given by this formula. Okay, student, it's clear. Then after that, it is also possible to calculate this one. Then move on to the limitation. The first limitation is it fails to account for the finer details of the hydrogen atom spectrum observed by using sophisticated spectroscopic technique. By using spectroscopic technique, it shows some absorption spectra, doublet, and that is two closely spaced lines. It's nothing but, according to him, only singlet is appear. What happened in that case? Doublet is doublet spectra. He never explained this doublet spectra. That's why this is a first limitation. And also, this model is also unable to explain the spectrum of atom other than hydrogen. This model is only explain spectrum of hydrogen only. We have many atom spectrum. For example, carbon atom spectrum is called carbon spectroscopy. C13 spectroscopy, NMR spectroscopy is there, and also fluorine spectroscopy, phosphorus spectroscopy, everything is there. It never explain these concepts, students. It can't explain. Only it explains hydrogen. That's why it fails. And also after that, it could not explain the ability of atom to form molecules by chemical bonds. Oh my God. One of the main drawback is it can't explain the formation of molecule. If it's not explained, this theory is really waste. Why? Because molecule is nothing but, in our nature we already know, the all atom exists in the form of a molecule. All atom or all element exists in the form of a molecule. If it's not explained this concept, then this theory is really waste, right, my dear student? This is a second drawback. Okay, next move on to the next model after the Bohr. Next move on to the quantum mechanical model of an atom. It is discovered by Broglie. Who is this fellow? Louis de Broglie, from 1890 to 1987. He is a French physicist. Oh my God, students. All scientists are physicists only. There is no chemist scientist. Imagine. That's why I told you guys, physical chemistry, it's like a brother of physics. Organic chemistry is like a brother of bio. Inorganic chemistry is like a brother of entire metals topic. That's why chemistry is very important. That's why, students, chemistry is a main subject. It's a main subject for entire JEE students also, for entire NEET student also. It is compulsory. If you want to become, or if you aim, oh, I want to become IITian, then chemistry is must and should be important. And also for NEET also chemistry important, especially organic. That's why your Suhas sir always teach organic. Okay, students, it's clear. Then dual behavior. In the view of shortcoming of the Bohr model, attempts were made to develop a more suitable and general model for atom. It fails, right, my dear students? That's why the other scientists come, Broglie's come, to develop a new model. Two important developments which contribute significantly in the formulation of such model. Where next model, which is the next model of atom, quantum mechanical model. Okay, according to which is the main point, which is the main For entire discovery or for any discovery student, we have some motivation. For example, what happens, some other teachers give some motivation related to subjects. Read student, if you read you can easily grown up, and something is give that give that some motivation, right? I never give any motivation, students. You should motivate yourself. Always you should motivate yourself. If you motivate yourself, then you can easily grow up. Like me, no people, never, I never go with any other peoples. I never go with any other people. I am only motivate myself. And you know one thing, I am also last bencher. You know my score. My score always above 90% in my degree and my masters. Students, nothing depends upon you guys. It is very easy. Everything is very easy. Just concentrate. That's all. Just concentrate. That's all. Dual behavior of matter and also Einstein uncertainty principle. Okay. First point is dual behavior of matter. Second one, Einstein uncertainty principle. Very important principle, my dear students. Dual behavior. Come on, let's discuss dual behavior. This Broglie in 1924 proposed that matter, like radiation, should also exhibit dual behavior. Matter, radiation, everything exhibit dual behavior. Is nothing but it shows both wave and also particle. Wave nature also, particle nature also. Okay, my dear students. This means that this is photon as momentum as well as wavelength. Electron should also have momentum as well as wavelength. Proton and electron both as momentum also, wavelength also. Wavelength, lambda also, and frequency also, momentum. Okay, my dear students. Then after that, between wavelength and momentum of a particle, he gives some relation. Okay, next one, first uncertainty principle. Einstein uncertainty principle, it is very important. According to this, it states that it is impossible to determine the simultaneously the exact position and exact momentum of an electron. What he told, it is impossible. We cannot determine the exact position and the exact momentum of an electron. We cannot determine. Why, students? Electron always revolve around the nucleus, is right? It moving around the nucleus with certain speed, with certain momentum, with certain energy, and any certain, okay, different. Always it is different. That it is never, we cannot never predict or never determine the exact position and moment of an electron. Okay, students, this is very important. This is a statement. It is mathematically told like this: del x into del px, it's always greater than or equal to h by 4 pi value. This is an uncertainty principle mathematical form. Very important. Where del x is the uncertainty in position, del px or del vx is the uncertainty in momentum. Del x correspond to position, del vx correspond to momentum. Okay, students, this about this thing. Next, significance. What is the use of this one? First significant is it rules out existence of definite paths or trajectories of electrons and other similar particles. What it rules? It gives some idea about trajectories and the path of a electron and other particles like proton and other thing. The effect of Einstein uncertainty principle is significant only for motion of microscopic object, and it is negligible that of macroscopic. It is only focused on microscopic, not a macroscopic. I repeat once, it is only focused on microscopic. It's negligible macroscopic. The visible atom is there now. Some visible particle, it negligible this thing, microscopic particle. It only focus on microscopic. According to that, this is a formula: del V into del x is equal to h by 4 pi m. Then substitute the value. It's all approximately equal to 10 power minus 28 per meter square per second. Okay, my dear students. The value of del V del x obtained is extremely small and it is insignificant. What? The value is there now. The product value of del V del x, uncertainty in momentum and uncertainty in position is there now. It is always extremely small and insignificant. It is always small because it is 10 power minus 28, my dear students. 10 power minus 28, just imagine that thing, right? Then after that, in this case of microscopic object like an electron, on the other hand, del V del x obtained is much larger and such uncertainties of real consequence. But for microscopic, it is little bit high. For example, this thing is happened 10 power minus 4. For microscopic, this for microscopic. Okay, students, it's clear. It therefore means that if one tries to find the exact location of the electron, say to an uncertainty of only 10 power minus 8 meter, then the uncertainty del V in velocity would be this one. Okay, it's clear. Then let's move for the quantum mechanical model of an atom. After this model, we have principal quantum number. Type of quantum number is there. Quantum atomic model. Types of quantum number, atomic number, principal, azimuthal, and azimuthal quantum number, and magnetic orbital quantum number. Their representation, how we represent L. What is the representation? Very important. And after that, s orbital, subshell notation, and number of orbital notation, and electronic. What is the meaning of electronic spin, 2 spin, and the shape of atomic orbitals? How s orbital look like, how p orbital look like, what is the dimension, and also what is the energy of orbitals, and after that, arrangement of orbitals with the energy, then filling of orbitals. Very important principle, Hofbauer principle, and after that, Pauli exclusion principle, and after that, electronic configuration. This is a last topic. We have still so many topics. This is a long unit. This is a long unit, my dear students. This is an entire structure of atom. Totally, it has around 14 to 15 periods. It's nothing but this unit. It's around 14 to 15 hours. Now, I am only simplify entire basic concepts, student. Don't worry. After this, I definitely explain everything. Sir, class eppudu finish potandi. I have online class at 3 o'clock. Yes, it's exactly finished at 3. Bagunnara Mahalakshmi. Mahalakshmi, you are bagunna? I know little bit Telugu due to Sumaya. Sumaya, you know, right? Sumaya is my friend. Okay, students, come on, let's discuss. Okay, where is the thing? Heisenberg is done. Significance also done. Then let's move for the last atomic theory of this unit, structure of atom. The theory named the next is quantum mechanical model of atom, right? Quantum mechanical model of atom. According to this is also called as in quantum mechanics. Here, one important terminology is this Schrödinger equation. This Schrödinger equation plays very important role. Whenever you enter your higher studies in chemistry and other things, this is very important. Miru, I'm also bagunda. Sorry, bagundao. I know little bit. Sorry for that, students. Okay. What is this meaning? In classical mechanics, based on Newton's laws of motion. 3 Newton's law. Right, student? Newton first law, second law, third law. We already know that. Successfully describe the motion of all macroscopic objects. Newton's law mainly describe entire macroscopic objects such as falling stone, orbiting planets, etc., which have essentially particle-like behavior as shown in the previous section. However, it fails applied to microscopic objects like electron, atoms, molecule, etc. But Newton's law fails, students, to apply microscopic. It's only applicable for macroscopic. It's not applicable for microscopic. Okay, students. This is mainly because of the fact that classical mechanics ignores the concepts of dual behavior of matter, especially for subatomic particles, and the uncertainty principle, the branch of science that takes into account. So, okay, into account this dual behavior of matter is called quantum mechanics. What is quantum mechanics? The study of microscopic particles in dual nature. This study, this part of mechanics is called quantum mechanics. Classical mechanics is nothing but the study of macroscopic. Quantum mechanics is nothing but microscopic. Quantum mechanics is a theoretical science that deals with the study of the motion of the microscopic objects. I already told you guys. Quantum mechanics, it is a deal or it is a study. It is a study of microscopic particle, my dear students. Quantum mechanics was developed independently in 1926 by Werner Heisenberg. Heisenberg uncertainty principle we discussed, right? Heisenberg only discovered this quantum mechanics, students. Here, however, we shall discussing the quantum mechanics which is based on the ideas of wave motion. It is completely depends upon idea of wave motion, my dear students. Was developed by Schrödinger and second scientist. He is also one of the main contributor for quantum mechanics. First one Heisenberg, second one Schrödinger. Schrödinger wave equation is there, students. It's very important in quantum mechanics. For a system, the Schrödinger equation is written as this one. H psi is equal to E psi. This is called Schrödinger equation. Very important equation. Where H is mathematical operator called Hamiltonian. What is called Hamiltonian. It is called Hamiltonian. This operator gave receipts of constructing this operator from the expression for the total energy of the system. By using this, we find total energy of the system. Okay. Then hydrogen atom under Schrödinger equation. Hydrogen atom. When Schrödinger equation is solved for hydrogen atom, the solution gives the possible energy levels the electron can occupy and the corresponding wave function of the electron associate with each energy level. In the time of discovery of Schrödinger equation, students, in the time of discovery of Schrödinger equation, it gives an idea about energy levels and the entire energy associated with that energy level. Here we divide the energy level into few types. First one is called principal quantum number, azimuthal quantum number and magnetic quantum number. These three are very important. We divide the energy numbers or three quantum numbers. Or here one important is there. This quantized energy states and corresponding wave function which are characterized by three quantum numbers. These are the three types of quantum number. In your syllabus, totally we have three types of quantum number. First quantum number, n is nothing but principal quantum number, L is nothing but azimuthal, and M is nothing but spin. Okay, magnetic, and also S is nothing but spin quantum number. It is another subset or another sub part of magnetic quantum number only, my dear students. In L plus 1, minus 1 is there, everything is there. Come on, let's discuss that one. The principal quantum number, it is denoted in n. It's a positive integer with a value of n is equal to 1, 2, 3. Okay. The principal quantum number determines the size and to large extent the energy of the orbital. What it mainly describes, the students, what it mainly describes? It mainly describes the size, the entire size of an atom and also the energy extension in the orbit. In the orbit, the energy gets extended, students. This quantum number, this principal quantum number describe this thing. What, Pinky? What is the meaning of V? Pinky, what is the meaning of V? V is nothing but velocity, right? It's not a physics class, Pinky. Okay, this about principal quantum number, it is denoted by n, and also after that the principal quantum number also identify the shell. What shell? K shell, L shell, M shell. Depends upon the n value. For example, n is equal to 1, 2, 3, shell is equal to K element. We are already familiar with this one. Size of an orbital increase with increase of principal quantum number. If n value is increases, then size of the atom also increases. Very important. Principal quantum number describes the size of atom and extents of energy of orbit. Okay, students, I repeat once again. Principal quantum number, it is described in the symbol of n. It is denoted by n. If n is increases, then the size of an atom also increases. Then more to the azimuthal quantum number, it is denoted by L. It is also called as an orbital angular momentum or subsidiary quantum number. What is the another name of azimuthal quantum number, my dear student? It is also called as orbital angular momentum or subsidiary quantum number. It defines the three-dimensional shape of the orbital. Not a principal quantum number describe the size. Azimuthal quantum number describe the size of an orbital. Hi Ganesh. Hi Ganesh. Hi. Okay students, I hope it's clear. And also it is denoted by the symbol L. Okay, the possible values of L are 0, but azimuthal quantum number start with 0, but not a principal quantum number. Definitely they ask in exam. They ask the difference between azimuthal and principal quantum number. On the time you need to write entire relevant topics. Okay, for principal quantum number, it is nothing but it describes the size of an atom and also the energy associated with orbital, and also it is denoted by n. If n is increases, size of an atom also increases. Right, my dear students? Hi Ganesh. Next, in the case of azimuthal, it completely describes the structure of an orbit. It is also called as orbital quantum number or orbital angular momentum. It is denoted by L. Principal quantum number never be 0. Never the value of principal quantum number is 0, but azimuthal quantum number, it describes the 0 value also. I hope it's clear, students. Here, each cell consists of one or more subcells. In each cell, We know, right? We have some shell, K shells. In K shells there is no subshells. In L shell we have some subshells also. Okay, L shell, in some subshell also is there. For example, this one. N value 1, 0 is correspond to 1s value, N value 2, 0, 2s value, 2 value 1, 2p, 3s, 3p, this thing. 4s value, the azimuthal quantum number if 0, then it is correspond to s rotation or s notation. If it's 1, it is correspond to p notation. If it's 2, it is correspond to d, 3f and other things. Sir, after this, please give us break for 10 minutes. Okay, definitely I give break, Pinky. I give break. After the explaining of this concept, magnetic orbital quantum number, I give break, ma. Okay, Pinky? Okay, students. Next, move on to the magnetic orbital quantum number. Now we discuss entire physical. Always physical chemistry is coming in the mind, students. Principal quantum number, azimuthal is done. Okay, azimuthal is referred to shape and subshell. It is referred to always shape of an orbit and subshell. It always explains that concept. Then after this magnetic quantum number, it is denoted in the symbol M. It is the spatial orientation of the orbit with respect to standard set of coordinate axes. What it gave? It is always related with this orbital structure. Okay, orbital structure. Hi, Dams. Oh, hi, Dams. I'm good. How are you, Dams? How are you? Okay, students, thus L is equal to 0, then the value becomes like this. M value always is negative. It's nothing but minus L minus 1, and this thing is happen. Sometime M value is negative, positive, something is happened. Okay, my dear students, I hope it's clear. Then after this is a subshell notation and number of orbitals is present like this. Then next mode, the last one, electronic spin. After this, I give break, Pinky. Definitely I give break. After the electronic spin quantum number is denoted in the symbol S. Either it has only two value, either plus 1 by 2, minus 1 by 2. It's completely depending upon spin. If we represent in upward direction, then its charge is always plus 1 by 2. Its spin quantum number or its charge is plus 1 by 2. If we represent in reverse form or downward form, then this is correspond to minus 1 by 2. It is very simple, students. Here we have few concepts here, few points here. To sum up, the 4 quantum numbers provide the following information. By all 4 quantum numbers, they provide some information here. And define the shell, determines the size of the orbital and large extent the energy of the orbital. Entire quantum number, principal quantum number, describe the n value is there now. If you know n value, you can easily tell the shell, which shell the electron is there, which shell is outermost valence electron shell, and the size of an atom, and also large extent of their energy. It's also told, it's also explained the extent energy of orbital. Okay, it's clear, students. Then second point, there are n subshells in the nth shell. L identify the subshell. N is always represent to the subshell. N is represent to the identify the subshell, and M represents the shape. Okay, LP and everything. It's M designates the orientation of the orbital. For a given value of L, M1 has 2L plus 1 values, the same as the orbital per subshell. It means that thing. Okay, it means that. Okay, this is a last point. Okay, students, I give some summarized part. I give some clarify here, students. Clarity about everything regarding about quantum numbers. Students, here mainly we discuss 3 type of quantum numbers. First one is principal. This principal quantum number, it denotes in the symbol N. It denotes as a symbol N. This quantum number describes entire relation between the shell, which shell the electron is there, and also the energy associated, the extent in the energy is there now in the orbit. What is the energy associated with the orbit? It gives, and also size of an atom. This about physical quantum number. So physical, not principal quantum number. Second one, azimuthal. This azimuthal give the shape of an orbital. For example, which subshell the electron is there? Shell is divided into subshell. The entire L is there now. It entire L describe the shape. Then after the M is there now. This give the orientation, in which orientation it shows. For example, it is in the outer, it is in the parallel orientation, or in above orientation, above the plane, below the plane, this one. second azimuthal quantum number is azimuthal quantum number. It denotes in the symbol L. It denotes as a L. Okay, it denotes as in the symbol L. Okay, student, this about quantum number. I hope it's clear. Then move on to the shape of atomic orbitals. Before entering to the shape particles, Pinky asked the break now. That's why I give 5 minutes break. Okay, Pinky. After 5 minutes, the session continues. Now 5 minutes break. Okay, Pinky. Now happy, Pinky. I hope you are happy. Okay. Yes, students. Let's take 5 minutes break. Yes, students. Hi, Pinky. No, okay, Pinky. No, I hope you are. You asked for 5 minutes break. I give that. Come on, now let's continue the topic. Next, move on to the shape of atomic orbitals. Okay, where we get these shapes? In azimuthal quantum number. In L, we get this shape, right, student? In shape, we have mainly three types. Okay, S, D, P, and F. S, P, D, F. Four orbital is there. S orbital looks like a ball. What ball? Cricket ball and any other ball. Hello, sir. Is it a break? Srinivas, now break is done. Srinivas, now break is done. Now we continue the session. Okay. Now we continue the shape of an orbital, my dear students. Students, in mainly we discuss mainly four orbit. Up to till you write electronic configuration as a number 2, 8, 10. Write that. Okay, depends upon the shell. But now onwards, in class 11th onwards, we write electronic configuration as subshells. As 2s1 form, 1s1 form, 1p, 2p, 3p, 3d, 4s, 5p, something is there. 5f is there. My dear students, very difficult now. Students, s orbital look like say ball. This is an s orbital shape. 2s orbital little bit larger than 1s. Compared to 1s, the atomic radii or the radius is there now. 2s, it's little bit more. That's very simple, my dear students. This about s orbital shape. This is an p orbital. P as a dumbbell shape. S as normal orbital shape, ball shape. P as dumbbell shape. Two orbitals. Two s orbitals join to form p orbital. This is in the 2px. It is in 3D shape, students. In px, it's look like py shape, this one, pz shape, this one. Okay. This about p shape, s shape orbitals. Then move on to the d shape. This one is d. This one is d, students. This double shape, d orbital as double shape like this. This is an called as an dxy, dyz, and dxz, dx square minus y square, and dz square. Totally we have 5 orbitals. We represent in this case s in 1 box, p in 3 box, d in 5 box. F, we don't have specific shape for F, students. Up to D we have shape. S is an orbital shape, P is a dumbbell shape, D is a double shape. Okay, my dear students. In S only we have 1s, 2s, 3s, that form. Sir, I have to leave. Okay, bye Mahalakshmi. You have 3, you have online class, right Mahalakshmi? Okay, Mahalakshmi, leave. Okay, bye Mahalakshmi. Yes, bye. Students, look here, concentrate here, my dear students. We have totally 4 orbitals. In azimuthal quantum number, under azimuthal quantum number, we discuss the shape of orbital. S orbital has orbital shape, P orbital has dumbbell shape, D orbital has double shape, F orbital has no shape. It is a different shape. Does not have any shape. It's always free in where? It is always free in where? Come on, let us know. Where? Come on, let us know in chat section. If you know, let us know in chat section, my dear students. And we represent in the excited state form. This one is very important. What happened? In 2s orbital, the electron present in 2s orbital, whenever we give energy, this 2s orbital electron jumps to 3s. This energy level or energy difference called as an del E, energy difference. Okay, this about in energy, whenever the absorption, the energy get absorbed, the electron jumps. Similarly, same electron, if we after absorbing its jump, after emitting the energy, what happened? The electron returns to their original orbitals. In the jumping, it gains energy. Whenever the electron jumps from lower energy state to another higher energy state, it gains energy. Similarly, whenever the electrons coming backwards, whenever the electron jumps from higher energies to lower energy, what happened? Energy get releases. How much energy absorbs now that electron? Same energy only, that electron releases the energy. Okay, students, clear? In the jumping from lower energy, the electron move from lower energy. Okay, just imagine this. These are the energy levels. This is 2s, this is 3s. What happened? From 2s to 3s, the electron jumps. The electron jumps happens whenever on that case the energy get absorbed from the surroundings. Similarly, same electrons comes back towards the same its original energy shell or its original energy subshell, what happened? It emits the energy. Super, super, Srinivas, it's correct. It's correct. What happens, Srinivas? If jumps from lower energy to higher energy, it absorbs. Similarly, it comes back to its original energy shell. It releases its energy, my dear students. What happened? It releases. Very simple. For example, take an example. Take an example of climbing a tree. If you want to climb a tree or if you want to climb any building or anything, you use some, sorry, okay. You use some stepway, right? Whenever you go through stepway for climb a tree or climb a stepway, what happened? You need higher energy or you need require some energy. Similarly, when you come upwards to downwards, okay, up to down, first floor to down floor, what happened? You simply come like this. You don't need high energy, right, students? Similarly, in electron, very simple. Whenever it jumps from lower energy to higher energy, it releases energy. Similarly, whenever it jumps from higher energy to lower energy, sorry, my students, jump from lower to higher, it absorbs. If it's come back higher to lower, it releases. Very simple. Now it's clear, students? Yes, I hope it's clear. Then this is an arrangement of orbitals with increasing order on the basis of n plus 1 rule. Okay, n plus 1 rule basis. If 1s, what is the value of principal quantum number for 1s orbital is 1, 2s2, 2p2, 3s3, 3p, 4s, 3d and 4p. Okay, students, this is a format. Where is that one? Next, move on to the last topic of your structure of atom unit. Last topic, my dear student, this one. Filling of orbitals in atom. How orbitals get filling? We already know atoms has number of valence shell. In Bohr's theory or in Bohr's atomic model, he told about valency. This is a special orbit when in this orbit or orbital, the electrons are revolving around the nucleus. In this orbit, never the electron radiate any energy. We already know about in this case. What happens, students? This is an entire schematic, okay? This is an entire representation. First, 1s is come. After we need to fill the electron to 2s. After the 2p and after the 3s, 3p, 3d. After 3d, then we come to 4s. Then 4p, 4d, 4s is then. First we fill 1s. After 2s. Then after 2s we go to 2p. Then after 2p, then we come to 3s. And 3s after the 3s, we come to 3p. 3p after 3p, after 4s. And after 3d. After 3d, 4p. And after 4p, 5s. 5p after 4d, 5p, 6s. 6p, 6s is done. Yes, 6s, 4f, 5d, 6p, 7s. This thing is happened. Okay, students, this is about filling part. Then here, one important principle is there. Aufbau principle. Aufbau principle, very important question for your board exams. This Aufbau means building up. Okay, according to this principle, it states that in the ground state of the atoms, the orbitals are filled in the order of their increasing energy. How it filling? Order of their increasing energy. It fills according to the order of increasing energy, my dear students. Okay. How it's filling? According to Aufbau principle, it fills according to their increasing in order of energy. Okay. If energy is increases, then the electron also filling in subshells. Up to till we only know about energy or the electron filling in shells. Now we are discussing energy filling in subshell like s orbital, p and d. If we have subshell, right? That's why. Yes, super Srinivas, it's correct only. However, the following energy of the orbital is extremely useful. First, it's filled 1s. After 1s, 2s. S orbital, the maximum elements or the maximum electron fill in s orbital is 2. P orbital, how much? 6. D orbital 10. F orbital 40. These 4 are very important. We can only fill 2 electron in S subshell. We can only fill 6 electron in P subshell. For example, let's take an example of hydrogen. Electronic configuration is 1s2, helium 2 is there. 1s1, helium 1s2, lithium, hydrogen H, helium H, lithium Li. 3 is right. Lithium 3 is nothing but 1s2, 2s1. After filling s orbital, 1s orbital, next we need to move to the Next we move towards 2s orbital. After 2s orbital, after we move towards 1p. Okay, first 1s, 2s. No, there is no 1p. Is there 2p? After 2p, after 2p 6, 3s. After 3s 2, 3p 6. After 3p 6, 4s 2. Instead of going 3d, after 3p 6 we feel 4s 2 electron, and after that 3d 10. This is an entire electronic configuration format. Depends upon number of electron, we write electronic configuration. For example, come on, let's write here electronic configuration for few atom. For example, take carbon as example. What is the atomic number? Totally 6 electron is present in carbon atom. Right, students? What is the valency of carbon? 4, right? Yes, Suha sir, you only teach entire carbon and its units, or carbon and its compounds. You only told valency is 4. Up to till what we write in class 10? What is the electronic configuration of carbon? We write up to 2, 4 in the basis of K shell, L shell. But according to correct electronic configuration, or according to Aufbau principle, how we write? First we fill 1s orbital, 1s2, 2s2, then 2p2. This is an exact electronic configuration. Okay, students. According to this, we write electronic diagram as this side 1s2, 2s2, then in this 2p2. This is an energy cell notation, energy cell representation. Okay, students. Carbon is done. Then let's take any example, sodium example. We are familiar with sodium. What is the atomic number? 11. The exact configuration 2, 8, 1. This about shells, related to shell. What in the case of subshell? Come on, let's write here. First 1s2, 2s2, 2p6. Then after 2p, the electron jumps to 3s molecule. 3s1, right? This is an sodium electronic configuration. What in the case of 20 calcium? Let's take calcium example. Calcium example 20, right? 2, 8, 8. 10 to 18, 2. Right, students? This is an electronic configuration what we know up to till. Now, what is the electronic configuration of calcium? First 1s2, 2s2, 2p6, 3s2, 3pa. 2 to 4, 10, 12, 3p6, 18 is done, then 4s2. This is an actual electronic configuration. That's why after calcium we call those elements in periodic table. After calcium, what is come? Scandium, titanium, these are all called as an 3D element, 4D element, 5D, 6D. We divide as this much. After this F elements or F group, we divide entire periodic classification of elements or modern periodic table as 4 types, right, students? 4. S orbitals or S group, P group, D group, F group. In P is represent to the electron present in P shell. The outermost valence electron is there na, the electron present in P shell. Similarly, D is nothing but the electron present in D subshell. F, it's relevant to F shell, and S relevant to S subshell. Okay, my dear students, is clear? It's clear. I hope it's clear, everybody. Srinivas is clear, pa? Srinivas? It's clear. This is a filling form of an atom. Then after the Pauli exclusive principle, very important, my dear students. Please note down this one. Please note down this. According to this, what it states, no 2 electrons in an atom can have the same set of 4 quantum numbers. No 2 atoms is nothing but we have 4 set of quantum number, right, students? N number, L, M, and S. These are the 4 one. Spin quantum number is always +1/2, -1/2. If it's quantum number, if an atom has these 3 as same, then it has different spin. Either in +1/2 in form, -1/2 form. It's nothing but this one. That's why we represent as one as an forward symbol and another one as a reverse symbol. Okay, students? Srinivas? Yes, thank you so much. According to this Pauli exclusive principle, what it said? No 2 electrons in an atom. In an atom, we have number of electrons, right? Number of elements. No 2 elements, no 2 electrons, not an element. Electrons in an atom can have the same set of 4 quantum number. Either it difference in spin or in L quantum number or in M quantum number, any other quantum number. No one has same quantum numbers. Okay, students, very important principle. According to this, next move on to the unrule for maximum multiplicity. It states that Pairing of electrons in the orbitals belong to the same subcell P, D or F does not take place until each orbital belong to that subcell has got one electron each. That is, it is singly occupied. What happened? Pairing is there now. Up to filling of every orbital, pairing does not happen. For example, if you have 3 electron, instead of filling this type, if you fill this one, if you fill like this also, right, this is not happened. According to Einstein's principle, what it says that no pairing is happened up to filling all electron or up to filling all table. Very simple, students. For example, if you have 3 p orbitals, okay, 3 electrons in p subcell, then you need to mention like this. You need to write like this. Instead of write like this, you need to write like this. Okay, student, this is which one? Heinz rule. It's clear. This is an electronic configuration of atom. The electronic configuration of different atom can be represented in 2 ways. For example, SPD notation, orbital diagram. This is called orbital diagram. Very simple. For example, look here, my dear students. Before filling the entire orbitals, we cannot pair the atoms or pair the electrons. For example, look here, 3 is there. Instead of writing like this, we write or we fill entire orbit. After filling, we pair. We come to pairing of the electrons. Okay, like this. Okay, now it's clear. Up to all vacant shells are filled. As it's correct. Up to all vacant shells, up to all orbitals filling, we cannot pair. After filling all orbitals, we can easily pair it. Okay, students, it's clear. Okay. Then this is a few example for electronic configuration of elements. Hydrogen, helium, something is there. You can refer. It is there in your NCERT textbook. Okay, students, this is about entire structure of atom. Okay, finally we done the entire structure of atoms. Students, in this unit, mainly focus on the few principle, Haffu principle, Einstein's rule, and the uncertainty principle, and the electronic configuration, notation, structure of orbitals. These all are very important topics for your JEE and NEET concepts, or for your KSET exams or JEE exams or your competitive exams. And remaining theory particles are there, na theory parts. For example, theory parts is nothing but structure of an atom. The models are there, na quantum model. The dual nature, these are all not important, my dear students. Dual nature is there, another thing is there. These are not important, just not focus on that concept. Mainly focus on the representation. In exams, how can they ask? Very simple. They give some elements, okay, they give some either number, and they ask which is the correct notation, in this electron. For example, they give 36 electronic configuration, 36 element or 36 number of atomic number, 36 number. Then they ask what is the correct notation, or pick the correct notation in following option. That's thing they ask. So it's very important topic. Imagine, students, this unit have up to 14 periods. Your Suhas sir explain this unit within 2 hours 50 minutes. Just imagine that, students. This like a basics concepts. If you want, please subscribe the Diksha Vedantu Kannada channel. I explain entire topic with English and also Kannada. First I explain entire topic in English, and after that I explain in Kannada. Okay, students, please subscribe the channel. I told the subscribe. I told again the channel name Diksha Vedantu Kannada. In that channel, I teach entire organic chemistry. I think this unit is taught by Ankita ma'am because she take entire physical topics. Okay, students. Hi, Sudish. How are you, Sudish? Sudish, you asked some question, right? In comment section on that video, you ask, sir, what is the use of percentage? Students, I give some clarification about subject or about percentage, students. Students, I told one thing. Marks never give or marks never judge you people. This only chapter 1 na Sudesh, I think on next week definitely I do that. Next week definitely I do that. Please watch the session. Sudesh, it is very important session, students. First unit I teach in next week. I think in next week periodic classification of elements is there na, and that's unit also I teach. Yes, sir, I asked. Students, marks never judge you. If some people take 90%, some people take 70%. In Kannada, one famous song is there. ಲಾಸ್ಟು ಬೆಂಚಲ್ಲಿ ಕುಂತೋನು ದೊಡ್ಡ ಕಂಪ್ನಿಲಿ ಯಜಮಾನ ಫಸ್ಟು ಬೆಂಚಿನ ಸ್ಟೂಡೆಂಟು ಅದೇ ಕಂಪ್ನಿಲಿ ಜವಾನ. ವಾಟ್ ಇಸ್ ದ meaning is the students, some people score good marks but they cannot pass in entrance exams. They are like bookworm. Students, please, this is an honorable request from your Suhas Bhaiya, your brother. From your brother's side, one honorable request is there. Please don't go with concept. Okay, please don't go with NCERT books or don't go. Simply, sir, I study, I write exam, I take good marks. This is not a perfect manner, students. Study the concept and think the concept in applicable level, not in NCERT textbook level. Think in application level. In your NEET and JEE exam, they ask application level questions. For example, here we discuss only azimuthal quantum number related some concepts, right? Azimuthal and spin quantum number and principal quantum number. But what they ask in exam, in JEE and NEET exams, they ask like, they give some notation here. Which one is this one? Which one this one? And they give element. You don't know the electronic configuration, you simply bias that one. Oh, carbon, it has 1s2, 2s2, 2p6. That thing has something. Okay. Sir, what is the difference between percentage and percentile in JEE or NEET? Students, percentage and percentile is very different. I don't have any idea about that things. I have some little bit idea. What I know, I explain you guys. Okay. In next class, I think and I do some experiment also. I do some research on that concept and I explain that. Percentile and percentage is different. Percentile is nothing but what you score in JEE. Students, in JEE and NEET, I think we have negative marking also. Please concentrate on that. Negative marks is nothing but if you write correctly. For example, first question, you tick something, it's correct, then you got 4 marks. Then after second question, you write wrong, then in 4 marks is there now, you have minus marking. In 4 marks they deduct half marks, then your correct marks becomes 3.5. This is a difference between percentile and percentage. That's why students, before writing any competitive exam, first think and write the answer. If you don't know the answer, just leave that question, just leave. Instead of losing negative marks, or if instead of losing marks, simply don't attend those questions. Okay students, don't worry. We are planning to launch new series called JEE and NEET series in the same channel and also in Kannada channel. Please support me, students. Sir, also could you teach how to calculate log and anti-log in chem? Okay, I teach it in one class. Sir, when will be next session? Srinivas, next session will be happen on tomorrow. Next session is an organic. Students, physical, really I am weak at physical, students. Tomorrow attend my session and after that session, please give a valuable feedback. Students, Srinivas, sorry for that. I do not ask feedback about today's session. Please give a valuable feedback, Srinivas, now. Please give. How was the teaching? It's good. I am also fresher, students. Now, in the month of February, only my results are came. Now only I complete my masters. You know my age, students. My age, now my exact age is 22 years. Okay. I am 22 years old guy. Teach entire JEE and NEET topic for you guys. Okay, just imagine my precious students. Now only I am completed my masters. Srinivas and Shudish, please give a valuable feedback. Yes, definitely I do that, man. Definitely, students. Okay, we do one thing, students. Simply I come one day live. I teach entire calculation part, how to convert log to anti-log and how to add few particles, and also we need to convert 10 power minus 19 to 10 power minus 18, how to convert the points, how to write in points, how to convert the entire from Celsius to Kelvin, how to convert the SI units, everything I do. Okay. Yeah. What's about first class? What is the opinion of my first class, Srinivas? It's good or bad? If I give you 5 marks, how much marks you give for me? If I the session for 5 marks, how much marks you give for me, Sudesh? How much marks you give for me for 5 marks or 5, sir? What is the feedback from your side? Okay. I do that. I think first class is taught by Ankita ma'am. I ask once with her. After that, I take that class. Okay, don't worry. But your teaching was so good, sir. From tomorrow, I will be attending regularly for camp. Thank you so much, Srinivas. Thank you so much. I need this feedback, students. If you really support me, then this is a promise from your Suhas brother. You can easily get out of 40 in your chemistry, NEET exam and JEE exams. Until your NEET and JEE exam, I am there, students. 4 to 5, 4.5. Thank you so much. Thank you so much, Pinky. Thank you so much. Don't worry, students. In upcoming class, I increase my teaching capabilities and other things. If you attend organic, students, please attend the organic sessions, because I am organic chemistry specialized teacher. It's nothing but I am only teaching entire organic part. I am never, sir, are you not tired? You have been teaching for long. Yes, Emma, I am not tired. If the tea is there for me, I never tire. Students, just imagine, ask Sudesh, when the maths exam happen, okay, it's okay. You can watch recorded session. You can watch after live session, Srinivas. At exactly 12, I take entire alcohol, phenol, and ether with chemical properties, with reactions, with other conduction, everything I teach students tomorrow class. Please attend it. Ask Sudesh, what happened, Emma? On exam, maths exam before. On maths exam is happened at March 11th, right? Before maths exam, I take 6 to 7 hours long session, students. Right, Sudesh? Okay, students, any doubt is there regarding about this subject? Sorry, about this atom. This atom, only, yes, this is atom. Imagine, we build some remote, but in remote, the entire small particle atom, it has so much knowledge. It has so much subtopics. Yappa. Right, students? Wow. Yes, Emma. In your exam time also, don't worry, Emma. I take morning classes. Emma, I am always serious. Whenever I take morning classes, you must and should be attend that class. Okay, Emma? At morning 5 o'clock, I take entire class for science and chemistry. Just imagine. Okay. Yes, students. Pinky, thank you so much for attending the class. Sir, took mega marathon and I watched the recorded for 2.5 max, sir. Yes, I took mega marathon, Sudesh. Sudesh, you already subscribed for Diksha Vedantu Kannada channel, right? Students, please share the channel for your friends, and also please subscribe the Kannada channel. Its name is Kannada only, but I teach entirely in English, students. I teach entirely in English on the channel. Please subscribe the channel. Please support the Kannada channel also. Okay, that's channel also. My channel only, our channel only, your channel, especially for your channel. Now the channel crossed 2.53k subscription, right, my dear students? Yes, share the channel, help to me, help to us, students, help to us, our entire Diksha team. Okay, if we grow, then you also grow. Please help to grow us. Okay, do one thing, students. Simply take your father and mother phone and please subscribe the channel from that. Okay. What? Sir, for my upcoming cycle test, I have chapter 1 and redox reaction. Okay, I take redox reaction unit. Chapter 1, I think Ankita ma'am, she is teaching. If she is not taking that chapter, I take that chapter. Okay, so I teach that chapter. Okay. Yes, in Saturday, not in Saturday, in Monday, I take redox reaction chapter. Okay, Shudish, please attend that chapter. Okay, students, this is about today's class. Okay, Srinivas, bye, everybody. This is your Suhas sir, ending with a beautiful smile. Love you all. Thank you so much for attending the session. Thank you so much, Pinky, Srinivas. These two are our new students. Your Suhas brother. Students, stay free with me. Connect anytime. I give my Insta ID. My Insta ID is Suhas KS Gowda. My Insta ID is Suhas KS Gowda. You can follow me on my Insta also. My Instagram. And also please join the Telegram channel. And also students, we have one biggest surprise reveal at evening. Please attend the session. Okay. Bye students. Take care. Bye everybody. Follow me on my Insta.